You're listening to WUVT FM 90.7 Blacksburg. Good afternoon, everybody. You're listening to the fourth episode of Hokie Weather Watch, live right here on WUVT 90.7 FM Blacksburg. And for those of you that don't know, Hokie Weather Watch Live is a radio talk show geared towards the only thing that impacts all of us, the weather. The science, the communication, or even the pop culture influences that the weather brings to our daily lives. We're going to touch on it all. So thanks for tuning in. Now it's time to get to know some of our panelists because, as you know, every single week we have somebody new. So, Jamie, start us off, man.
Yeah, this is my second episode here. My name is Jamie Morrow. For those that don't know, I was a student here. I got a Bachelor of Science and Bachelor of Arts in Meteorology and Geography. Graduated about 2 years ago, 2.5 years ago, and I'm currently working on my master's, and I also work for the National Weather Service in Blacksburg. So
okay.
Yeah.
I had to come up with a question this week.
Oh.
And I really struggled with this.
Mm-hmm.
So after lots of 5 minutes of thinking, this is what I came up with. What did you have for lunch for today?
Ooh, lunch. All right, that should
Isn't
be
that
an
a
easy
great
one.
question?
Right? Yeah, I love it. So actually, I went with the Old Faithful mac and cheese.
Okay.
Yeah, it was.
If it's not broke, don't fix it.
Yes,
Yep.
exactly,
Okay.
and it was all right. I overcooked it a little bit, so. But other than that, no, it was a good meal.
Okay.
Yeah.
All right. Aaron, what's up, man?
How's it going, Nick? I am a junior here at Virginia Tech, and I am studying meteorology. I am also the lead meteorologist here at Hokie Weather Watch.
Okay. Nice. What did you have for lunch?
I had a meatball marinara sub.
Oh.
Oh my gosh.
It was fantastic.
It sounds lit.
Mm-hmm.
Oh, yeah.
It was.
Oh, there it is.
Count one.
Lit count one.
Should we keep a tally of that?
We did last week.
Yeah.
We did.
Also, last week I said that it was our fourth episode. It was actually our third, so I apologize for that.
Yeah.
Don't hate me.
Counting's never been your strong suit.
It
huh?
really is not. I'm so sorry. Caitlin, how are you doing?
Good. I am Caitlin Purcell. I am a sophomore here at Virginia Tech, studying communications with a minor in meteorology.
Okay.
Current incumbent WUVT chief meteorologist. I love weather.
Okay.
Oh, yeah.
That's all I got to say.
Don't we all? What'd you have for lunch?
Well, actually, Jamie, not gonna lie, I had mac and cheese for breakfast.
Oh,
So,
man.
For lunch, we're switching
Plot
things up.
twist.
I have a chicken Caesar wrap.
Okay.
So yeah.
Nice.
Currently in her lap right
Yeah.
now.
Currently taking bites.
Spoiler alert. And then our guest today is Stephanie Zick. How are you doing today?
Good, thanks.
Can you tell us a little bit? We're going to talk to you more a little bit later on in the presentation, but can you just give us a little introduction?
So I am an assistant professor in the geography department, professor of meteorology, and I just started this year. And I'm a tropical meteorologist, so it's been a busy couple of weeks.
Days.
I mean, well, generally this season, but especially these last couple of weeks,
Okay.
yes.
Well, I do have to ask you, should we be calling you Dr. Zick or Stephanie? How would you like us to, on the radio, how would you like to be known?
For this show, we can do Stephanie, we can
Okay.
go by.
But back in the classroom,
in
it's
the
Dr.
classroom, it's doctor or professor.
Zick. Okay.
Yes.
Strictly
All right.
business.
All right. What'd you have for lunch today?
So my husband actually ran the half marathon that was here,
The Hokie
and
half.
yeah, so after he was finished, we had some scrambled eggs.
Okay.
And
protein
so I guess it
intake
was
again.
breakfast
That's
for
right.
lunch, and I had a bagel with pumpkin cream cheese.
Okay.
Oh, man.
So jealous.
Sounds really good.
Yeah. Great weather for that marathon today, too.
Oh, yeah,
I
totally.
mean, couldn't have asked for a better autumn-type day
Absolutely.
to run that thing. So.
For sure. So we've got a great show for you today. And what better timing to dedicate a show to tropical meteorology for sure. We're going to have an interview with Stephanie, as we talked about. We're going to talk all about the tropics, Hurricane Matthew, all of that good stuff. But first, we want to make sure that you have the ability to interact with the show either live or throughout the rest of the week. So, Caitlin, can you let them know how they can do that?
Yeah, you can find us on Twitter and Instagram at the handle HokieWXWatch. And if you want to join the conversation, use the hashtag HokieWX.
Okay, thank you so much. All right, first things first, let's get through this interview. Stephanie, how's it going?
Good.
Super excited to be here.
Yeah, I am. That is actually, this is fun. This is my first time doing radio.
And you're killing it.
Yeah, so far.
Just killing it.
Blowing us out of the water, no question.
So, what got you into weather? I'm always curious about the story that gets people into meteorology? Excuse me, where the interest comes from? Was it from when you were really young? Was it something recently? What got you into weather?
I think I pretty much fit the model of a weather weenie who was very
Don't we all?
interested in the weather from a very young age. And I grew up in Pittsburgh, so
Ooh.
winter weather was of particular interest. I always wanted to understand snowstorms and how I could help forecast to when we'd have snow days off. And the blizzard of '93 was a big weather event for me. We the storm, most of the snow was dumped on like Friday and Saturday, as I remember. But we had Monday and Tuesday off from school. There was so much snow. We got 2 feet.
Wow.
So that was one of the big things. But I also was very interested in the tropics. We used to go and vacation in the Outer Banks. And so the 93 hurricane, or is 91 hurricane, oh man, I'm totally embarrassing
no,
myself.
you're fine.
Hurricane Bob. So that was also a big one. We had just been in the Outer Banks, and Jim Cantori was like one of the first times he went on location.
What?
And he was right outside the hotel that we had been at.
Wow.
So after that, that's when I remember tracking the tropics and always following the tropical weather update. And
Hurricane Bob was 91.
91, right.
Yeah, so another Jim
And
influenced
it
recruit.
skirted the Outer Banks. It didn't actually make landfall in the Outer Banks, but at the time they were saying that that's where it was likely to make landfall, and then ended up curving a little farther north.
Sounds kind of familiar to what just happened.
Yeah.
Totally.
Yeah.
Just last week.
Yeah. Very similar track between, well, at least in that aspect,
Right.
affecting the banks. But
Yeah.
we'll get into that a bit later.
We got to take a quick break for a PSA.
WUVT would like to thank all of its wonderful supporters for a successful radiothon. All premiums are now available for pickup at 350 Squire Center from 9 a.m. until 5 p.m. Monday through Friday. Stop by and allow us to thank you in person for your support.
Cool. Thanks, Caitlin. So, Stephanie, where did you go to school?
So I went for my undergraduate. I went to Rutgers University, and they have an environmental sciences department with meteorology major, which is I always like being here at Virginia Tech with the geography and meteorology. The two departments remind me a little bit of each other.
Okay.
But then I did my master's at Penn State University, and that's when I got to embark on tropical cyclone research specifically.
Okay.
I spent a couple of years after my master's at the Naval Postgraduate School, which is in Monterey, California.
Oh, wow.
And they have an excellent tropical meteorology department. It was a great mentoring experience for me. I got to be involved in a field project in 2008. They were sampling storms all the way from tropical cyclogenesis in the West Pacific all the way through extratropical transition. And there were specific science questions, and I was a forecaster for the field project.
That's awesome.
So that was my real experience with learning how to forecast in the tropics.
Okay.
And then I went back for my PhD, University of Florida, and that was a PhD in geography. But we're studying spatial aspects of tropical cyclone rainfall. So that was what my dissertation was on.
Okay. Nice. So out of all of those places, how does Blacksburg compare?
Oh, yeah.
Different world here, right?
Well, visiting here reminded me very much of State College. State College, I think, it's similar in size. It's in the valley, Happy Valley, and being a college town. So I met my husband at Penn State, and we both really fell in love with Blacksburg when we came and visited.
Okay. That's awesome. Sorry. Let's move on to talking a little bit more about what your specialty is here in meteorology, and that's the tropics, as you said. So tell us, just give us a rundown of what exactly is tropical meteorology. What makes it different from forecasting regularly? What does it entail? Is it just hurricanes, or are there other things that tropical meteorology entails?
Right. So I've been actually thinking a lot about this. I think it's a great question. What is the difference between tropical meteorology, especially if we're thinking about forecasting, versus forecasting in the mid-latitudes? So I'm developing this tropical meteorology class that I'll be teaching in the spring, and that is sort of going to be the theme throughout the class, because there are some very important differences. Maybe I can ask the panel, like, what are
Ooh,
some
quiz.
Oh man.
Oh snap.
Put on the spot
What are, like-
here.
maybe go Aaron. What do you
Okay.
think?
Can you repeat
Sorry
the
to
question?
throw you on the trap.
That's okay.
What's some things that come to mind for differences between the tropics and the mid latitudes?
When I think of tropics, I think of the formation of like the birth of hurricanes and everything. And then when I think of the mid latitudes, I think of that's where they end up, and they end their tracks and their life in the mid latitudes.
Yeah, and they're very different structurally how the energetics are working throughout the life cycle of a tropical cyclone. It's very different depending on where it's located.
Right.
Yeah, so I mean, throughout the classes and stuff, some of the things I picked up on through modules and stuff is the difference between like a warm core versus a cold core type system. I know that plays a big role, but I can't necessarily explain the difference. So other than warm
yeah.
and cold.
Yeah, so if we're thinking about the tropical cyclone, this is great. There are two types of lows that we see in the atmosphere. The warm core low is what a tropical cyclone is, and it is fueled by latent heating. So the low pressure is actually warmer. The core of a tropical cyclone is warmer than its environment, and it forces convergence and rising air. The energetics of a mid-latitude cyclone are different. It gains its energy from the temperature gradient, essentially, between the tropics and the poles. And it's essentially getting its energetics both from that gradient, this baroclinic atmosphere, and the vertical structure in the mid-latitudes are such that the jet stream will provide upper-level divergence that is favorable for cyclogenesis. So it's sort of the combinations of those two things. We call this a baroclinic atmosphere, and that's how a mid-latitude cyclone gets its energy.
Okay, and that makes sense why, a tropical system comes on the land. It usually has a real difficult time staying organized versus you see the mid-latitude ones that will circle over us for sometimes days on end and not have any weakening, at least not immediate effects by the land cover.
Yes, absolutely. So in order for the tropical cyclone to maintain or to intensify, there needs to be this latent heating very close to the center of the storm. And as it moves over land, it loses this underlying warm ocean, which is some of the energy source for the hurricane. So often it will basically be cut off. Sometimes they are able to maintain intensity a little bit if they're able to get enough moisture convergence to continue that latent heating.
Okay.
What's the basis for the science? Like, why is it important for us to know, to have a handle on forecasting tropical meteorology? What are some of the hazards associated?
Oh, okay. So, as we're doing, so we never went a little bit further with the difference between the tropics and the mid-latitude. So I'll just
That's
say
okay.
a little bit, and I
That
think
is
I
okay.
can answer this question too.
Yeah.
Okay, so one major difference between the tropics and the mid-latitudes is that there's no strong temperature gradients. So as a corollary to that, there aren't strong pressure gradients. So in general, the atmosphere can be very quiescent from day to day. So if you're doing like just a day-to-day forecasting in the tropics, it's largely you're looking for where there would be enhanced convergence in the low levels and enhanced divergence in the upper levels to see where convection is going to be favored. And you're looking at basically the trade winds. So we have these easterly winds in the tropics, and you want to look at the flow. So you look at the low-level winds, and you look where there's basically confluence would be where convergence would be favored and where we could see convection happening. And especially in the Atlantic, when you're looking at forecasting, we have the African easterly waves. So those will really organize where the convection is happening, and you'll get these mesoscale convective systems, these thunderstorms that fire in these regions. And these easterly waves are regions where there's low-level convergence and upper-level divergence.
Oh, wow.
Okay.
So in reality, one of the drier places on the Earth's surface is actually one of the source regions for some of these waves that become something like Hurricane Matthew.
Yeah. Yeah, that's very interesting. Oh gosh. So yeah, the northern Africa, right? It's this desert. It's very dry. So whenever the energy comes in from the sun, a lot of the energy goes towards increasing the temperature. You get really, really warm temperatures there. And you end up getting a setup that's similar to the mid-latitudes where there can be a strong temperature gradient. And the African easterly jet, there's a similar sort of like baroclinic instability. At least that's one of the leading theories. It's called baroclinic barotropic instability because there's a little bit of instability coming from a few different mechanisms.
Okay. Thank you.
That was confusing.
Oh,
Am
no,
I getting
no.
really sciencey?
That's okay.
Yeah.
That's part of what we do here. So talking about the tropics and the hazards, how does that change? I'm curious about the changes that a hurricane goes through once it goes onto land. Can you talk about that process a little bit? Like what happens? What are some of the different things that can happen to a hurricane when it hits land?
Okay, so I think I'll go like a first route. There's sort of two pathways that we can sort of think about. One would be where it's just landfall, so we're not talking about any sort of interaction with the mid-latitudes. It's just making landfall. Maybe it's moving over Central America.
Right.
So what will generally happen is as there's less and less latent heating, the vortex will spin down. And often in interaction with the terrain, it'll also sort of just completely deform the vortex, so it gets destroyed by terrain, high terrain.
Okay.
So it can sort of spin down. That's one route. So we go dissipation is what I would call that. And then the second route would be, especially for recurving ones, if we're thinking about storms that make landfall in the U.S., they can interact with the mid-latitudes. And depending on the phase of the wave pattern in the mid-latitudes, they can either phase with that pattern and transition to extratropical, or there's some other pathways they can take where they don't phase well, and they sort of just end up dissipating as well, or they get absorbed.
Okay.
And the general public probably doesn't realize how fragile hurricanes actually are.
Right. For sure.
Yeah, I mean, they're powerful storms, but they rely on those energetics, and so especially with interaction with terrain, they can really just sort of get torn apart. Hurricane Patricia from last year
Wow, yeah.
was a
That
great
Mexico,
example.
right?
Yeah,
Yeah,
from
they
the
dodged
East Pac.
a bullet.
Yeah.
Yeah, so we talked a little bit about some of the things that made it go, and then you brought up terrain as one of the factors that start weakening it pretty rapidly oftentimes. What are some of the other weakening factors, even if it's not necessarily coming onto land? You hear about shear all the time. What other types of weakening factors can you have?
Right. So shear is one thing. So one thing about these warm core systems is they're vertically stacked. So as you go up through the atmosphere, where the spin is essentially like just on top of each other. And if there's shear, it can tilt the vortex. And that is not good for a tropical cyclone. It will tend to weaken, especially if vertical wind shear, this change of wind speed or direction with height, if that is coupled with dry air entrainment, so if there's dry air in the environment that gets entrained in, then that will inhibit the convection that it needs, so the latent heat release that it needs to maintain its intensity. So those are dry air and vertical wind shear are two of the big things that we look at if the tropical cyclone's still out over the open ocean.
Can you talk about a little bit what the difference between a hurricane is and just like your regular run-of-the-mill thunderstorm? Can you? Because I understand, and I feel like most of us here do. But what about the general public? Do they know the difference? Can you expand on that a little bit?
Oh, okay. So this is an interesting question. So thunderstorms. I mean, there are a few different types of thunderstorms, but if you just think of this ordinary thunderstorm,
Right.
They're much smaller in scale, and in sort of spatial scale, so they can be anywhere from 1 to a few kilometers wide spatially. And then the temporal scale is also short.
Mhm.
So actually, generally, if you're thinking about weather phenomena, the spatial scale is related to the temporal scale. So smaller scale phenomena don't last as long.
Right.
And that makes a lot of sense if you think about like little eddies that you see in sort of like around buildings. You'll see these little things spin up. They have really short time scales. So thunderstorms are sort of a little bit larger in scale than an eddy, but their temporal scale is also a little bit longer. It's more like an hour, or for larger thunderstorms where you have an organization into multiple cells, those can persist for a few hours. So the energetics in a thunderstorm, they're coming from instability in the atmosphere, where there's we end up having rising air because there's so much oh man. So near the surface, for instance, during the day, this surface heats up.
Right.
And that leads to instability that can be triggered.
Rising air.
Right. So
Yeah.
you have rising air and you have precipitation that forms. So a thunderstorm is literally just these ordinary one-cell storms that will form are due to this instability that develops in the atmosphere, usually with convective or with the daytime heating that we see, especially near the surface during the day. And that will trigger rising air and a thunderstorm if it rises up high enough. And so it's sort of like there's this updraft, and the cloud forms, and then thunderstorm forms, right? So you get these thunderstorm clouds. They go up and they go down,
What goes up must come back down.
right?
Yeah.
So that's like a classic thunderstorm.
Okay.
For a tropical cyclone, tropical cyclones are even larger in scale.
Right.
So on average, they're like hundreds of kilometers wide. And they can last for days. So days to weeks. So these are even larger disturbances. And their energetics then are fueled. They don't generally exist because of this concept of instability in the atmosphere. There actually isn't a lot of instability in the tropics. So they're getting their energetics from this latent heat release. And there needs to be a lot of latent heat release that will sort of fuel the spin up of the storm.
Right. Okay. Cool. Thank you. Anybody have any other questions on our panel?
You covered them all.
Yeah,
Sweet.
and one thing that might have slipped by is it's a tropical system's need for warm ocean temperatures. Usually, I know there's been some cases where the temperatures aren't necessarily warm. In fact, in January we actually had last January we had a tropical system, our first named storm in the Atlantic, which isn't unheard of but pretty rare.
It's pretty rare, yeah, but
Yeah, so how important is, I guess you kept talking about latent heat. That is one of the big drivers, is having that source of warm warm water that's producing the moisture in the
right.
ocean,
So
right?
latent heating is essentially, we say latent heat happens whenever basically condensation is happening in the atmosphere. So that's water vapor condensing into liquid cloud droplets. So that is the energy that is fueling these storms. But that the water vapor is sourced from that underlying ocean. So whenever ocean temperatures are warmer, there is more evaporation. Just on average, there's more evaporation, so there's more water vapor that can condense. So a controlling factor is the sea surface temperature. So generally speaking, a good rule of thumb is that hurricanes, tropical cyclones can form over ocean waters that are above about 80 degrees Fahrenheit.
Okay. Cool. Thank you. All right. Well, we're going to take a quick break. We'll continue talking about the tropics, Hurricane Matthew, all of that good stuff here in just a moment. So please join us back here on Hooky Weather Watch Live. right, welcome back to Hokie Weather Watch Live on WUVT FM 90.7 Blacksburg. So, all of our show today is dedicated to the tropics. Next thing up, we're going to talk about Hurricane Matthew because it's been in the news a lot over the past week. So, Jamie, give us some updates about this.
Yeah, it sure has been a top story. I don't think I've seen a news outlet not talking about it.
This is true.
I'm even this far inland, and we did get some effects from it, but certainly nothing compared to what further east saw. So I'm just going to give you a quick quick history of where the storm originated, stuff like that. So Matthew started as a tropical wave, like we were talking about earlier, over Africa, and it meandered in the easterlies, like we brought up earlier. I'm trying to build up all everything we talked about, Stephanie.
Easterly wave.
So it started as a wave and kind of meandered its way in a pretty, straight to the west type direction all the way into the central Caribbean. Where it took an abrupt, right after it was named, it took an abrupt northerly turn, and it was pretty drastic. In fact, I know for quite a few times, the first couple models weather models that indicated it, people were like, what are they thinking? And then it happened to be that
it's weird. We were in here last week, and it was just kind of like leaning out there, and we're like, oh, what's it going to do?
Yeah. And it did take that northern turn, and in fact, it got a top 5, right? Mm-hmm. What were you telling me earlier? It was the third, and during this turn, or right
before the turn.
Yeah, right before the turn. It had its third strongest rapid intensification?
So the third strongest rapid intensification in the Atlantic on record.
Wow.
That's impressive.
And that's behind, many may remember Wilma from 2005, and many may not as much remember Felix from 2007, but...
Wow.
Yeah. So it moved into this favorable environment for intensification, sort of, in that favorable in that there were warm ocean temperatures over a depth of the ocean. So not just another factor we just talked about, the importance of sea surface temperature, but in particular, if there are warm waters through some depth of the surface of the ocean, then that in particular is favorable.
Yeah, because, a lot of times, and especially during this turn to the north, it was going very slow, only moving maybe 100 miles a day or less in that circumstance. And I know a lot of times with these systems, we have what's called upwelling, where it uses up the warm water and all the turbulence and wind actually mixes up some of the colder waters at the surface. And in this case, if there's plenty of warm water in depth, like you were talking about, it's allowed to continue its intensification.
Yeah, that does help somewhat. And the track was really interesting, too. It moved so far west and stayed at such a south latitude because this subtropical ridge, this high pressure that we see in the subtropics, had expanded very far west. And the easterly trades were very strong. So it was being essentially steered around this ridge, and it made it into the Caribbean. It was a very, very far south in terms of latitude. It was a very low latitude. I think it was the strongest intensity in the Atlantic at such a south latitude. Wow. I think that was another record. But at that point, it sort of was at this point where it was around the ridge, and there was a trough that had dug pretty deep into the Gulf. And it had left behind, there was sort of this upper level low that was left behind. So it was sort of reaching this point where it slowed down quite a lot. And it didn't exactly take like a sharp north turn so much as it slowed down a lot to like basically stalled. It stalled over the Caribbean there. Right. And it did a little loop, and then it essentially started to turn to the north in between this upper level low and the extent of the ridge. So then it started to be steered north through that sort of trajectory, right?
Yeah.
North towards Haiti.
So that crazy 90-degree turn is not typically usual.
Yeah,
right?
So it doesn't, and it wouldn't really do that.
Yeah.
It wouldn't be going along at a strong pace and then make such a strong turn like that. So it was more like it slowed down so much, and then it started to move northward.
Yeah.
Yeah.
And going back to the intensification, I'm pretty sure, and someone correct me if I'm wrong, it went from a Cat 1 hurricane to a Cat 5, the strongest category that a hurricane can be rated in a less than a 24-hour period. It really, 2 or 3 airplane flights through it, and it went from one of the lower, there's some evacuations, not many if it was going to hit land, but to, worst case
major
scenario
hurricane.
if it were to come on shore at that point. So it was a pretty rapid intensification in that, especially for a system like this, so large of a system.
Yeah, so this was okay. So the third on record, the third fastest rapid intensification in the Atlantic, and so I saw 80 miles per hour in 80 miles per hour intensification in a 24-hour period. So
Wow.
This is very rapid.
Yeah.
And what was notable about that was we talked about how vertical wind shear is not good for tropical cyclones, and that is true. But we do have some recent research that is looking at where is this vertical wind shear in the atmosphere. So traditionally, we use a metric that is the average vertical wind shear between. We just take the 850 millibar winds, so pretty low in the atmosphere, and the 200 millibar winds, and we look at the difference between these two layers, and that is generally what we have used for forecasting. But it's starting to show that if there's a little bit of shear higher up in the atmosphere, that's not too detrimental. So in this case, most of the shear was in the upper atmosphere, and there was very little vertical wind shear between 850 and 500 millibars. There was basically no vertical wind shear. So we think that is why it was able to rapidly intensify. So we weren't really getting a tilted vortex so much in this like crucial sort of most of the atmosphere. It was pretty favorable, and we were not getting entrainment of dry air. So that is the current theory on that.
Awesome.
Wow. So yeah, it was certainly, even well before it made any impacts on land, it was an interesting storm to watch, and of course it took a northern trajectory and kind of meandered its way up north through the Caribbean and actually impacted. It almost tried to shoot the gap. It's very hard to but it tried to shoot the gap between Haiti and Cuba, and unfortunately it did make landfall twice. I believe at least the first time when it hit Haiti was a Category 4 hurricane. And when it went over Cuba, it might have been a 3. It was a minimum of 3, but and in both areas, we're especially Haiti, we're talking some very concerning, and they are poverty type, especially that portion of the country. There's a lot of poverty, and the structures aren't as well built as most American type structures, and they certainly saw the brunt of this storm. And in fact, I think the current death toll numbers, and these are current as of earlier this morning, are over 800, actually approaching 900.
That's insane.
Yeah, deaths as this thing came ashore, and that's from, that's a very mountainous region. There's very few trees in that region left because that's one of their big fuel sources. When they want to stay warm in a tropical island like that, you don't have the coal, you don't have that sort of thing, and in a poverty-stricken island, you don't have the imports like some other places have. So, mudslides are a huge concern there, and I know that had when you're dumping 18, 20 inches in some spots, you're just doomed to see some entire mountainsides come down, and unfortunately that is what happened there. So those were some of the effects down a little bit farther south off of our mainland, and after a short PSA we will talk about some of the effects it had in the U.S. and have a brief forecast of our own.
Did you know that Blacksburg has a vintage market? It is held in the Market Square in downtown Blacksburg every second Sunday of the month from 10 a.m. to 5 p.m. Vendors offer a variety of vintage vinyl, clothing, upcycled wares, and other vintage treats. For more information, you can visit www.facebook.com/Blacksburg Vintage Market.
Cool. Thanks, Caitlin. So some of the impacts here in the U.S., storm surge, wind, inland flooding. At least 15 have died in 4 southeastern states. Over 900 people alone were rescued in North Carolina. Did
you say 900?
900.
Yeah, from floodwaters.
Yeah, a lot of that was inland flooding. There were some from the evacuated areas that stayed and they had to be rescued, but a lot of that 900 was actually inland. Parts of Raleigh, parts of a little bit farther west, the New Bern area, they saw a tremendous amount of rain, and all up across the Carolinas saw anywhere from 10 to 15 inches. So.
People probably think, oh, I'm so far inland, I don't have to worry about evacuating.
Well, that's the concern. You hear a lot of this stuff like, all right, I think for the most part, and there are always going to be the people that want to stay toward the shore, we'll ride this thing out, we've been through worse. there'll always be those people, but for the most part, the majority
Yeah.
listen to their mayors, listen to their local officials, and evacuate properly. But a lot of the evacuees went inland, 100, 200 miles, thinking they were safe. And when this
Still lots of
thing,
rain.
yeah, when this thing became a left of track rainfall type system, and there's a lot of dynamics in play. Maybe Stephanie, you can talk a little bit on why that precipitation kind of maximized there, but. They saw anywhere from 10 to 15 inches in a very short amount of time. So you have flash flooding issues, you have river flooding issues that are still ongoing, and it was just a terrible time for those people in those states.
Yeah, well, we actually talked about this in class the other day. One of my professors, Dave Carroll, great man, he went on for a while about how it's dangerous because we kind of missed than what we were supposed to have. We missed a run of the storm, so it was more of the outer bands. Like Florida was fairly lucky in that it didn't directly make landfall. So people are thinking, oh, like we rode out a Category 4 storm, like so next time you have a bigger one, like, even like a Category 2 making actual direct landfall, people are like, oh, well, we were able to ride out a Cat 4, so I'm just gonna wait it out, and that's where it becomes dangerous.
Yeah, so I mean, in terms of rainfall, in particular, if you're thinking about impacts, there's not a good correlation between the Saffir-Simpson hurricane wind scale and category and rainfall. So you can get really devastating impacts from storms that are not even Category 1. You can have tropical storms that dump a lot of rainfall and have massive impacts with inland flooding. And I mean, a great example of that was Tropical Storm Allison from 2001, and there was a lot of devastating flooding in the Houston area. But it happens, and it's I think it's a real challenge for the forecasters in communicating the impacts. I know the National Weather Service has been really moving towards putting out these key messages.
Right.
Yeah.
So Jamie, I'm sure, is good and well aware of that.
Shameless plug.
So that to really focus on the impacts and not so much what is the peak sustained wind, which is just like one wind barb in one part of the storm or whatever. Like that is important. But actually, from tropical cyclones, 90% of deaths are from water-related hazards, so either from storm surge or from inland flooding. And depending on the period that you average over, so for instance, if you looked over 30 years that included Katrina, the statistics are heavily towards the storm surge. But they had done some studies at the impacts prior to Katrina, sort of going from like 1970 to 2000, and during that period 50% of deaths were from inland flooding.
Wow.
So that's a big important part of what needs to be communicated to the public for these events.
And communication is going to be key going forward, and I think education as well. You tell people they need to evacuate, and so if I'm told to evacuate, I evacuate. So the question is, why do some people, and this is getting into a huge realm that we're not going to be able to go into today, but a shout out to possibly next week's episode. We're actually going to be talking about some of this stuff, but we had some serious flooding issues, whether it's from rainfall or the initial storm surge. There were reports of storm surge in Savannah up to 17 feet, I believe. I mean, it's well above what you were thinking. And the fact is, and you kind of touched on it a bit, the storm was actually weakening when it got up there. And then it weakened even further when it produced all this flooding in parts of North Carolina. So just because it's a Category 4 or now it's extratropical like it currently is, you have different type of effects, and trying to determine what those effects are going to be is still a challenge. If it's a 100-mile-an-hour wind, you're going to have trees down. You're going to have buildings that are being torn apart. Those effects we're well aware of just from past research and stuff. But, being able to tell 3 days out that 200 miles inland you're going to have serious flooding is a little bit more difficult. And it's certainly steps that we're going to be taking in the future, trying to figure out, and it's going to be a top priority here coming soon. I touched on it a bit. The storm is currently a extratropical cyclone. We kind of talked about that post-tropical type characteristic versus a current hurricane type characteristics, but basically made the transition from a warm core to a cold core as it was interacting and weakening with some of the land and jet stream. a couple
Yeah.
fronts, right?
It became frontal.
Yeah, yeah.
It was one of the main reasons that it was designated. So it loses its warm core characteristics and it becomes frontal. So there's like basically a warm and a
Sector.
cold
Yeah.
side. Yeah.
Yeah, and the winds are still kicking. I know this morning there were still reports out of North Carolina, especially late last night, of gusts up to 100, even as an extratropical cyclone. So you certainly still have some of these effects that are well known, and we are currently actually, and Aaron's going to be talking to you about this. We're currently here from an associated type wind field, wind advisory. So these things can have effects inland, and we touched a bit on that. But you have the coastal where the mile or so from maybe a little bit farther when it comes to the wind effects, but the surge only goes inland about a mile, give or take, depending on your terrain. And then you have the wind effects that extend a little bit further inland, but then you have this flooding type threat. So there's certainly some differences when it comes to, all right, what's my threat with a Cat 4 coming ashore versus what's my threat inland after it weakens and becomes something else. So there's still some debate, or still some room to grow as a forecaster on trying to determine what some of these threats are. But for the most part, what's your opinion? Do you think this was a well forecasted type system, or sorry to put you on the spot?
Yeah. I think, especially, I think that they might get a little bit criticized for the forecast for Florida, because it ended up staying. So they have the cone for the track, and it did stay within the cone, but the track they thought it might go a little bit closer to land, and it did not. And the impacts ended up being quite a lot different. So the impacts in Florida were not nearly as severe as they might have been, but then you look at later on, and I do think with any storm that's moving towards land like that, they do focus on the inland flooding being one of the factors in the forecast. But I think that in this particular case, for a variety of factors that I can't get into right now, but the precipitation was even more intense than we had expected.
Yeah, so I know you can't get into a lot of those things now, but is that a good advertisement to take your class here in a few next semester?
Well, it's going to be a lab course, and one of the labs will be hurricane forecasting, and well, there'll be a one about TC structure, but and then there's another one that's going to be more focused on as you're for land, what are the rainfall forecast, heavy rainfall forecast with that.
Okay.
Sign me up.
Yeah, totally. I wish I could take the class, but I graduated.
You can sit in if there's room, right?
Well, it's time for our weekly forecast. Aaron, take it away, man.
All right, well, this one's going to be pretty quick and simple for you
Short and
guys.
sweet. I love it.
All right, so we're actually in a wind advisory right now. So the reason why we're in a wind advisory is because we're having possible gusts up above 40 miles per hour. So those can be pretty devastating at some points if the ground is saturated or anything. But we're going to stay into that wind advisory until 6 p.m. So it's going to be expiring here in about an hour or so. But looking forward into the work week, we're going to have beautiful fall-like conditions, and they're going to be here and here to stay for the week. For the beginning of the work week, the high temperatures will be in the mid-60s, and the lows will be around 40 degrees. Kind of even dipping into 30s. So like
It's
high 30s.
here.
It
Oh
is.
man, I have the morning shift this week, so it's gonna be chilly out there, huh?
Have fun with that balloon launch. Throughout the week, the temperatures are going to slowly begin to rise to around the highs around 70, and then the clear skies will be expected to stay here throughout the rest of the week.
Nice.
Woohoo.
Yeah, the Blacksburg climate treating you well so far, Stephanie. I know we had one of the hottest summers on record here. I think it was top 10. So
Later in the summer, especially, it seems to just extend for a longer time. But it's not like Florida, where I've been, where it's basically summer through November. So I am enjoying it. And as I told my intro students, this post-cold front weather is my favorite.
yeah, it's fantastic time to be in the New River Valley, especially you get about 2 weeks every season that is just drop dead gorgeous around here, and with the leaves will be changing here before you know it. I think our peak comes in another couple of weeks. You'll really start seeing the greenage start dropping and some colorful mountain colors around here. So
You're hiking in now.
Oh yeah,
That's awesome.
Well, I can, before I send it off to Nick to close out the show, I can guarantee you, at least from my perspective, and I think it's a unanimous decision, you are our favorite professor to be on with us so far. You're also the first professor to be on with us so far, but I think you're gonna rank at least top 3.
I'm honored.
Well, thank you so much for being with us, and it's been an honor to talk to you. So.
Thanks for having me.
Yes, thank you, Stephanie, so much. Jamie, who do we have next week?
Oh yeah, we have some more exciting guests coming in. Looks like next week we might be talking to Jen Henderson, who's working on her PhD, actually finishing up her PhD here at Virginia Tech.
That's awesome.
She's more on the social side of meteorology. You know how people how people interpret some of these warnings, and we'll be talking a little bit about that with her next week. And in 2 weeks, you'll actually be hearing from my coworker Phil Heisel, who's the warning coordination meteorologist with National Weather Service in Blacksburg. So, unfortunately, I won't be here either of these 2 weeks. So,
you tend to do that to us.
Yeah, I know. Sorry, I set up all these exciting interviews and I just poke in every now and then. But I think you have some great shows coming up.
Cool.
So it should be a good time.
Thanks, Jamie. Yeah. I just want to give a shameless plug for our blog. You did a detailed post on Matthew, correct?
Yeah.
Okay, and that is, what is the blog's?
You can find it just by going to HWWLive at .wordpress.com. So
okay, cool.
Right,
so be sure to check that out, everybody.
Yeah.
As always, you can join the conversation, #HokeyWX. You can follow us on Twitter at HokeyWXWatch and tell us how we're doing at WUVTFM. Stephanie, again, thank you so much for being here.
Yeah.
Thanks.
Jamie, Caitlin, Aaron, thank
Always
you so
a pleasure.
much.
Mm-hmm.
It's always been real.
4 down. We'll be hitting top 5 soon. They'll be offering
yeah.
retirement here, and before you know it. So
Are you paying for that?
I hope Woobit is. We'll see. No, getting a shake from it. No, that's not happening. So.
All right, guys. Thanks so much for being here for episode 4 of Hokie Weather Watch Live. I'm Nick Gilmore, and we'll see you next week.
We say cold in the go. The brother common sense never stop with the flow. My flow keeps going on and on, and I like to do it cause I deep in the corners, and I'm not the type to beat like that.